talked about the definitions of the 6 trig functions in terms of x, y, and r. And in that, I also talked about which ones were reciprocals of one another. So what's the reciprocal of sine?
Cosine.
Yes. So sine is y over r. So when you do the reciprocal, it's r over y, which that is cosecant. And likewise, if I knew cosecant, you could just flip it and you would have sine. So if you know one of those, you automatically know the other. Which trig function is the reciprocal of cosine? Secant. And which one is the reciprocal of tangent? Cotangent. So that's the first thing this talks about. I want to take a second and talk about something on your calculators. If you guys would grab one real quick. So, in general, when we think of a negative power, we think of flipping something. If you'll notice on your calculator, there are sine, cosine, and tangent buttons. There are not cotangent, secant, or cosecant buttons. If you look above those, you see sine -1, cosine -1, tangent -1. On your calculator, that does not mean the reciprocal. Okay, so if you want cosecant, do not use that sine to the -1 thinking it will flip it. Okay, it actually represents the inverse, which we will talk about later on. We're not there yet. But just know that if you have like a decimal and you're trying to find the reciprocal, just type in 1 divided by that decimal. Okay, do not use the -1 buttons right now. All right, here is our first problem of the day. I want to find tangent of theta if cotangent of theta is equal to 4. So I did not give you x, y, and r, but do you know what tangent of theta would have to be? Yeah, it's the reciprocal. This is like 4 over 1, so tangent would be 1 over 4. You just flip it. Okay. B, I want secant of theta if cosine is -2 over radical 20. So, what do? Flip it, so it'd be negative radical 20 over 2. Now, should I leave it like this? No. What can you do with the square root of 20? Radical 4, radical 5, so that's -2 radical 5 over 2. 2's drop and we just get negative radical 5. Alright, so if you know one, it's easy to find the reciprocal. Just, if it's already a fraction, flip it. If it's not written as a fraction, just put it over 1 and flip it. Okay? Second thing I want to talk about is the signs of the trig functions. Now in section 3, we kind of had some homework problems that asked us this. It would say in quadrant 3, y over x, and you have to decide if that would be positive or negative. If you guys are following along in your book, like I'm sure you do, you go home and read the book to make sure I didn't lie to you. You'll see they give you a big table with every trig function in every quadrant and tell you if it's positive or negative. And we can do that, but I think it's easier to do this. So in quadrant 1, is x positive or negative? Positive. Y is positive and r is positive. So if you divide any positive numbers, you get positive. So in quadrant 1, they are all positive. Okay, if we think about quadrant 2, x is negative, y is positive. Okay, so if you think about sine, y over r, that would be positive, which means its reciprocal would also be positive. If you think about cosine, x over r, that would be negative. So that means its reciprocal, secant, would also be negative. If you think about tangent, y over x, it would be negative. So cotangent is also negative. So in quadrant 2, there's only two positive ones. Sine and its reciprocal, cosecant, are positive. If it's not positive, it's negative, so everything else is negative there. In quadrant 3, x is negative, y is, alright, so would sine be positive or negative? Negative. Cosine would be negative. What about tangent? Positive. Y divided by x, negative divided by negative, would be positive. So that means tangent and its reciprocal will always have the same sign, so tangent and cotangent are positive then. So in quadrant 4, x is positive, y is negative. So is sine positive or negative? Negative. Cosine is positive, and tangent would be negative. So cosine and its reciprocal secant are positive. Everything else is negative. Alright, now, do you have to memorize this? Not really, because didn't we figure everyone out as we went through it? Yeah, so you can think through it. This is just kind of talking about the pattern. A trick you will hear me say a lot. I will say all students take calculus. And this trick tells us where things are positive. In quadrant 1, A, they're all positive. In quadrant 2, S is for sine, so sine is positive. And we know if one function is positive, its reciprocal is also positive. In quadrant 3, take, T is for tangent. Quadrant 4, calculus, C is for cosine. So all students take calculus tells us what's positive. And if it's not positive, then it's negative. Does that make sense to everybody? Let's look at some topics. I just want to know the signs of the trig functions of an angle and standard position with a given measure. So we know, can I just make a table instead of writing all 6 trig functions for each of these? Would that be okay? We know sine and what other function will always be the same? Cosecant. We know that tangent, or let me do it in the same order I normally do. Cosine and which one are the same? Secant, because they're reciprocals, and tangent will always be the same as cotangent. Okay. So, first one I'm asking is for 54 degrees. What quadrant is that in? Quadrant 1. So if we think about all students take calculus in quadrant 1, what do we know? All of these are positive. 260 degrees. What quadrant is 260 in? Yeah, because we know quadrant 1 is between 0 and 90. Quadrant 2 is between 90 and 180. Quadrant 3 is between 180 and 270. So this is quadrant 3. Okay, quadrant 3 is T for take. So that means tangent's positive, so the others are negative. C. What do you do with a negative angle? Okay, if we add 360, we get 300. What quadrant is 300 in? Okay, so in quadrant 4, what's true? Good. So that means the others are negative. Alright, so if I give you any angle, you should be able to figure out if the trig function is positive or negative, just based off the quadrant. Is that okay? Next question. I'm going to give us some information and I'm going to decide which quadrant we are in from that information. Okay, so the first one. I'm going to tell you tangent theta is greater than 0, cosecant theta is less than 0. Let me give you a second to write. When I say tangent theta is greater than 0, what does that mean? Alright, so let's think about this. Every trig function is positive in 2 quadrants and negative in 2 quadrants. Where is tangent positive? Quadrant 3, all students take, and also in quadrant 1, because in quadrant 1 they're all positive. So I know right now, because of this, we could either be in quadrant 1 or quadrant 3. Second thing, cosecant is less than 0. Less than 0 means negative. Cosecant is the reciprocal of what? Sine. So I'm asking you, when is sine negative? So in quadrant 1 they're all positive. Students, in quadrant 2 sine is positive. So it would be negative in 3 and 4. So which quadrant worked for both of them? Yeah, the third quadrant is the only one that satisfied both of those, so we have to be in quadrant 3. E. Sine theta is greater than 0. What does greater than 0 mean? Right. When is sine positive? 1 and 2, all students. Cosecant theta is greater than 0, so that means it is positive. Cosecant is the reciprocal of sine, so it's positive when sine is positive, which is 1 and 2. So this time I have 2 answers. It could be in quadrant 1 or quadrant 2. Both of those work. Is that okay? So there's basically 2 other pieces that we need to look at today. The first one is the range of these trig functions. Range is talking about what these functions might be equal to. You know, we can plug in any angle, but we don't always get out just any answer. This is the first time we're talking about range, but we will talk about it several more times. we'll be focusing on these trig functions with talking about triangles again later on, so we'll revisit the idea of range then. We will later be graphing these trig functions, so we'll revisit the idea of range again. So we're just kind of throwing it out there, but we will be coming back to it over time. So it turns out that some of these trig functions have something in common. Sine and cosine actually have similar ranges. Their reciprocals, cosecant and secant, have the same range. And then tangent and cotangent have the same range. I want to kind of talk about why these ranges are what they are instead of just telling you. How do you find sine? Y divided by r. How do you find cosine? Okay. So we have talked about, if you think of this as a triangle, this is your x, your y, your r. What has to be the biggest side? R. Okay, so if you take a number and divide it by something bigger, are you getting an answer more or less than 1? If I take a number, divide it by a bigger number, so like 3 over 5, 7 over 8, 9 over 10, your answer is always less than 1, right? Have we ever seen a case where sine is equal to 1 exactly? Without like these quadrantal angles that we talked about yesterday? Didn't we get it to be 1? Could it be negative? Yeah, we just got done talking about sine is positive in quadrants 1 and 2, it's negative in 3 and 4. So it turns out sine and cosine, you can only get answers between -1 and +1. You'll never get an answer bigger than 1 or smaller than -1. Now cosecant and secant are the reciprocals. So with those, it's flipping it. It's r divided by y or r divided by x. Now r is now the bigger number. So if you take 10 over 5 or 10 over 8 or 10 over 9, what kind of number are you getting? Bigger than 1. Now it could equal 1 if you're on a quadrant where your r and your y are the same. And we could also have negatives. So secant and cosecant are really the opposite of sine and cosine. You get things smaller than -1 or bigger than +1. You don't get anything in between. So only things bigger than +1 or smaller than -1. Tangent and cotangent. We get those by dividing x and y. Is there any rule about which one has to be bigger there? No. X and y can be any numbers. So tangent and cotangent, you can actually get anything out. So tangent and cotangent can equal anything. Okay, so what I want you to do, take this information, what we just said our possible answers are. I want you to look at the next few problems and decide if each of these things are possible or impossible. All right, is it possible for cotangent to equal this? So tangent and cotangent, we said, can be anything. So can cotangent equal a -0.999? Yes, that one was possible. We said sine and cosine have to be between -1 and +1. So can cosine be a -1.7? No. Okay, we said cosecant and secant are basically everything except those things between -1 and 1. So it can be smaller than -1 or bigger than +1. So can it equal 0? No, that one's impossible. Because we can't have anything between -1 and 1. Alright, questions there? Like I said, we will see more of these. This is just kind of the first time we're touching on it. Okay, let's do this problem. Angle theta is in quadrant 3. And tangent of theta is equal to 8/5. I want the other 6 or the other 5 trig functions because I gave you the first one. Okay, we were doing these on last night's homework, but I either gave you x and y or I gave you an equation to find x and y. How do you get tangent? Okay, so what's my x? What's my y? Why did I tell you a quadrant? Yes. If you have a point in quadrant 3, then x should be -5. And y should be -8. Now tangent was positive because when you divide two negatives, it becomes positive. But we had to watch that quadrant to know that these should have really been negative numbers. Now we can get our r. R is the square root of x squared plus y squared. Square root of 89. Does that produce it all? No. And r is positive no matter what. So from here, the definition of sine is y divided by r. So that's -8/89. Are we done? No. Multiply by radical 89 on top and bottom, so we get -8 radical 89/89. How do we get cosecant? Oh, sorry, that's cosine. So let's do that. So x was -5, r is radical 89. Get the radical off the bottom, so -5 radical 89/89. Are you guys okay with me moving the radical without showing that I'm multiplying top and bottom by radical 89? Am I losing anybody there? Cosecant is the reciprocal of sine, and we talked about yesterday, where is it easier to flip? Yeah, so this would just be negative radical 89/8. Secant, you flip cosine, I would flip the one from before you moved the radical, so negative radical 89/5. I didn't do tangent because I already gave it to you in the problem. It was 8/5, so what's cotangent? 5/8. Now, mention. If at the beginning you didn't make your x and y negative, you can still figure it out at the end if you think about quadrant 3. All students take, so tangent and cotangent are positive, so you would just have to go back and add negatives to your other 4. So that would be another route of doing it. You just have to make sure you have the correct sign on the final answer. How are we doing? Do we need to stop, or you want me to keep going? Am I throwing too much at you today? What we have left are some identities. So I'm going to show you where they come from first instead of just giving you a bunch of formulas. So we'll write these down and maybe try 1 or 2 examples with them, and then I'll be done. So there are some formulas called the Pythagorean Idents. And again, all this stuff that I'm introducing you to in this section, it's not like this is a one and done, I'm showing it to you today and never again. We will cycle back and hit these several times. So this is just the first time we are seeing it. We know that x squared plus y squared equals r squared. We've seen that when we do the Pythagorean theorem to find that r in our triangles, or the formula for r. R is the square root of x squared plus y squared. So this formula comes from that. There's actually a few important results that come if we manipulate this formula. So for instance, if I took everything, we know that you can change an equation as long as you do the same thing to everything. So if I went through and divided everything by r squared, okay, x squared over r squared, that's like x over r squared. Y squared over r squared, so y over r squared. And r squared over r squared is 1. What is x over r? Cosine. Oh. So usually the notation, they put cosine squared, they put the cosine or the square after the cosine, just so it doesn't look like it's the angle that you're squaring. Plus, what is y divided by r? Sine. Equals 1. This is actually the first of our identities. Right now, you will never have to use this. I'm kind of giving you another tool in your toolbox that you can use to solve problems, kind of like when we did the x, y, and r. I showed you how to use a triangle, and some people really preferred that, but some of you never used it, and that's okay. This is something that some people really like it, and some people don't. I don't really care if you use it or not. I'm just giving you some options. So I'll show you how to use this in a minute, but we can get actually 2 more identities from this. So if I went back to the original, let's say instead of dividing by r, I divide by x squared. What's x squared divided by x squared? What's y divided by x? Tangent squared. What is r over x?
No, it's cotangent.
What's x over r?
Cosine.
X over r is cosine, and the reciprocal of cosine is secant. This might be one of those things where it's easier, like at the beginning of a test or quiz, just to, at the top of the paper, write down sine is y over r, cosine x over r, and then you've got it and you can look at it. Because when you have to run through the list in your head, it can take a while, but if you've got it in front of you, it's a lot easier. And there is a third one. What do you think I need to divide by this time?
1 squared.
Probably y squared.
What is x over y?
Cotangent.
Cosine.
What's y squared over y squared?
1.
And what's r divided by y?
Cosine.
Cosecant.
I see that one. Like this.
So here are the 3 Pythagorean identities. I tend to use the first one a lot. I use the others very, very little, but they are options for you. At this point, I'm not asking you to sit down and start memorizing a bunch of formulas. It would be helpful if you learned maybe the first one, cosine squared plus sine squared equals 1, because that is the most useful, but you don't need to try to memorize the other 2. Alright, there are 2 other identities that we have, and this is just kind of showing us all the ways these trig functions are connected to one another. So we've talked about reciprocals a lot. Quotient. Quotient happens when you divide 2 identities. So what happens if I take sine divided by cosine? What is the definition of sine?
Y over R.
Divided by. What is the definition of cosine?
Well, x over y.
To divide fractions, you flip and multiply. The first one stays the same, times, and you flip the second one. Those r's would cancel, and we get y over x, which is
How do you know this though?
I don't.
Like I don't remember like the formula. Like I just remember the name.
Bro, then how the heck do you?
I don't remember that.
Wait,
It's
you
why
said you only
stuff.
remember
I
the
don't
name,
know
you don't
it.
remember the.
Yeah, pretty much.
So how do you know it's tangent?
Well, like I'm talking about like when it comes like I can see the letters and stuff for it, but like I don't know the name.
you know CSC,
Yeah,
but you
like,
don't know
know
what
the-
that is.
Yeah,
Oh.
like I know the abbreviations.
I don't know. This.
So if sine divided by cosine is equal to tangent, what would be cosine divided by sine?
Probably cotangent.
Yeah, because it's the reciprocal, and the reciprocal of tangent is cotangent. So those are the 2 quotient identities. Questions here? Alright, so what I want to do is, let's say, one example, maybe 2 if we need a second one. These identities are things that can help you, but only if it makes sense to you. So if you don't like dealing with that, you actually don't have to. We are going to do a problem similar to one we already did. I'm going to tell you to find cosine and tangent. So I'm not making you find all the trig functions, only some of them. If sine is equal to negative radical 2 over 3, and cosine is greater than 0. We have options here. The first option is to do this problem like every other problem where you find x, y, and r and get your ratios from there. So I'm going to work it that way first, and then I'm going to show you how to do it with identities. Okay? So I have sine. What's the ratio for sine? So I should be able to get the y and the r right now. Everybody with me here? How do I know which one that negative goes with?
Probably the R.
No, because R is never
Oh.
negative, so it's positive.
Exactly. R is positive no matter what. So my y is the negative radical 2. My r is positive 3. Okay, can we get x? We can use the fact, so we know r is the square root of x squared plus y squared, so that means x squared plus y squared would have to equal r squared. We could also draw a triangle if that helps you. So we get x squared plus 2 equals 9. So x squared equals 7. Now when you add a square root, you have to do plus or minus. And we are going to decide that plus or minus from here. Cosine is positive. How do you get cosine? X over r. If that's going to be positive, then I need my x to be positive. It's not necessarily hard, but there's a lot of thought that goes into this, thinking about whether we need a positive or a negative. So now you could give me cosine. What's the definition of cosine?
R over, no, X over R.
That'd be radical 7 over 3. And you could give me tangent. Definition of tangent?
Y over X.
So negative radical 2 over radical 7. Get the radical off the bottom. Get negative radical 14 over 7.
What is that?
What is what?
The box. What is that?
This was my final answer because I asked you to find cosine and tangent.
Oh, okay.
Personally, I think this is still probably the fastest way to do these problems. And if you are confused in any way, shape, or form, I would stick to this way because we have done that over and over, and this method works on all of these problems. Can I also show you how these identities could be used to find it? So I'm showing you the identities. You don't have to use the identities. You can do x, y, and r. What I've given you is sine. I need cosine. Look at your identities. Do we have an identity that uses sine and cosine? Yeah, what is it? Cosine squared theta plus sine squared theta equals 1. So what we can do is substitute in. I told you that sine was what?
Negative square root of 2 pi over.
So we get cosine squared. Okay. Negative radical 2 squared will be 2. 3 squared is 9. So if I subtract that over, 1 minus 2 over 9 is 7 over 9. How do you get rid of a square? And when you add a square root, we do plus and minus. But I told you in the problem that cosine was positive, so it's a positive. Square root of 7 over square root of 9 is 3. And you'll notice that is the exact same thing. If you remember your identity. This can be faster. If you struggle with the identity, then it's probably easier to go X, Y, and R. So totally up to you guys. I also asked for tangent. I know sine and cosine, so how can I get tangent? Yeah. What about the quotient identities? We said.
Sine and cosine.
Mhm.
So, sine divided
Sine divided by cosine equals tangent. Sine was negative radical 2 over 3. Cosine was radical 7 over 3. To divide fractions, you flip and multiply. So you get negative radical 2 over radical 7. Multiply by radical 7 on top and bottom, and you get negative radical 14 over 7, which is the same thing we got before. Really, if you're only trying to find one thing, like if this problem had only asked for cosine, the identity is probably faster. If I ask for multiple trig functions, it's probably faster to do X, Y, and R. But I'm just trying to give you guys options for how to think about these problems, because there are lots of approaches we can use. You're also welcome, you could have done these by drawing a triangle and thinking about Sophotelic, so that is another option. Questions for me? Okay, so here's what we're going to do. I am probably just going to collect last night's homework because we don't have a ton of time left. I'm going to give you an assignment. We are going to have a work day on